Hello, and thank you for joining us today for the Network Analytics and Metrics on Steroids with Avi Networks and Grafana. Today we're joined by Matthew Karnowski, Solutions Architect at Avi Networks. Thank you for joining us today, Matt. If you don't mind, can we get started by telling the audience a little bit about yourself and your background, and then we'll go into a presentation and a live demo, followed by a Q&A at the end of the webinar.
Sure. Yep. Thank you for the introduction. As mentioned, my name is Matthew Karnowski, and I'm a solutions architect here at Avi Networks. I have roughly 17 years of industry experience. Most of that is focused heavily within data center infrastructures. Interesting side note, prior to working at Avi, I was a customer of Avi with a financial services company, and I was able to experience the benefit and the power firsthand of the advanced analytics that Avi provides, and that's what we'll be able, as we cover that today. And so these are real-world use cases, real-world deployments, and tried and true. Seen it work. We're going to spend a few minutes today discussing analytics, and as mentioned, we'll go into a demo, and we'll save time at the end for some Q&A. This webinar is being recorded, and it should be posted on our site shortly after the conclusion. So let's get started. So IT is changing. I guess a better way to say that IT has changed. We've seen workloads go from on-prem to public cloud, having hybrid cloud deployments, and then ultimately throwing in containers there as well. All of this feeds into a result of, we see automation now being adopted more widely, being used more heavily, resulting in larger scales of deployments. We're seeing infrastructure, and we're seeing application deployments at scales we haven't seen before as a result of the ease of use and the capacity available to us from the cloud environments. As a result, application teams now have a minimum set of expectations. They want cloud-like simplicity regardless of the deployment environment. Whether it's on-prem or in the public cloud, they want a similar user experience, simplified, and they want the ability to serve themselves. And so self-service culture has come from this. Application teams want the ability to have the ability to make changes on their own, going away from the paradigm of submitting a ticket and waiting for IT to perform those changes for you. The application teams now want to be empowered to make these changes on their own. And as a result of that, we're seeing IT become service-oriented organizations. From the ADC perspective and the load balancers, IT is now looking at the load balancer as a service, making sure that the service is available and has capacity, and then exposing minute configurations to application teams, empowering them to make configuration changes on their own. And to be able to manage these environments at scale and across multiple deployments, we're seeing consolidated metrics and analytics. Going away from having a tool per technology stack or even a tool per vendor to be able to get metrics and analytics, we're now going to looking at consolidated analytics. We have a single point to be able to gather all of the metrics. So single point to see visibility into the infrastructure. We're moving away from complex matrices of to get this information, go to this tool, or to get this information, go to that tool. We're now seeing a one-stop shop for all analytics and all metrics. Now, analytics, and so this is the crux of this webinar. This is what we're here to talk about. Getting visibility into analytics and how we can use those. So, what is the importance of even having our analytics? Well, analytics allow us to answer the questions essentially under three buckets: why, how, and what. Root cause investigations. What is going on? What is impacted? How did, what was the trigger? Why did this happen? Historical trending. How was our infrastructure performing on Cyber Monday? What was the impact to our infrastructure? Capacity planning. How much capacity do I currently have? How much am I going to need in the upcoming 1 to 3 years? And then just general performance. How is my infrastructure performing? What does it look like today? All of these are very, very important to get visibility and reporting on your infrastructure and what's going on. And we're seeing all this data becoming centralized, becoming consolidated, so it's easy to obtain and easy to report on. We have a quick poll that we'd like to throw up to get a feel for what you have, and if you currently do have any centralized metric solutions, or if you and if you do, what you're currently using. So we'll leave this poll up for roughly 15 to 30 seconds to gather your information. And then as the benefit of having these centralized metrics, we're able to expose this, and be able to consolidate across our stacks to understand, root cause investigations is a prime example. See the event correlation between compute, storage, network, and application, all within a single dashboard, a single spot. Okay. So before we jump deep into metrics, let's talk about Avi specifically and the architecture that Avi has. Looking here at your traditional appliance-based model, we have a pair of appliances and a bare metal deployment, and a separate pair of appliances in a virtualized environment, each managed independently. Consolidated control plane, data plane on the per box. So what Avi does is we've taken the control plane and data plane and we've broken that out. So we're a software-based solution, and this allows us to be able to scale these components independently. So data plane, what we call our service engines, is essentially the load balancers, and the control plane is that single point of management to control all of your service engines. And by breaking this out, we were able to scale them up independently from one another. If we need more data plane resources, we can add more service engines. So as I mentioned, this is a centralized management. With this controller-based architecture, we're able to deploy service engines in different environments, but maintaining a centralized point of management. Instead of managing independent service engines, you're managing what is in essence a fabric of service engines. We're showing here we have the service engine deployed in a bare metal environment and multiple service engines deployed and virtualized, all the while being managed from one singular controller. As load balancers have become integral part from the applications, we have a wealth of information that flows through the load balancers. Avi takes advantage of this and actually captures all of this metrics and analytics, and out of the box, we display this or provide this information on a per application basis. We were able to capture throughput, connections per second, SSL transactions, all the while providing logging information from HTTP headers, status response codes, even advanced analytics for the HTTP requests. And as a software solution, we're able to be deployed in any environment with extreme ease, be it public cloud, a container environment, virtualized, or bare metal. And all this, again, can be managed from a single point of, single controller, or single point of management. So what are the advantages that Avi brings? So Avi brings always on, fully integrated metrics. Out of the box, you get full analytics for your virtual services or your applications. It's not an add-on. This isn't a feature that needs to be enabled at a later date. This is straight out. This is straight out of the box functionality we provide. 100% REST API. As we're going into cloud environments, automation is obviously key. Any information that is in the controller can be obtained via the API. Any operation can be performed on the controller, can be performed via API. Is that the separate control plane, data plane, we're flexible and scalable, centralized management, applications on a granular basis per application, or metrics on a granular per application basis. And as I getting prepared for this webinar, I took a quick look at how many metrics we actually provide, and there was over 1,000 unique data points that we can pull from the controller. This ranges from frames received on the service engine to runtime user metrics or real-time user metrics for virtual services or the applications. What are the challenges we've historically seen with our ADCs, our load balancing infrastructure? One of the ones that always hit me was the limited metrics that were available, and generally those were rolled up at the appliance level. You weren't able to obtain per application metrics from the load balancer. And if you were able to obtain those, it generally required add-ons. And with these add-ons, there always came at a cost, be it performance, scale, or price. And then for some of the other software load balancers that are available, we're missing metrics like client performance, security insights, or round trip times. Now, as this webinar is discuss Avi and Grafana, I want to touch real quick on what Grafana actually is. So Grafana is an open source visualization and monitoring application which supports numerous backend data sources. It provides a single pane of glass displaying data for all of these unique data sources, being able to aggregate to that single point. And so the power there is you could have, as we're looking at consolidation of all of our index and logs, it's still 100% not there. So what Grafana allows us to do is aggregate these data sources into a single pane of glass. So you may have data sources for compute in one, you may have compute and analytics in one data source and network in another, and Grafana over the top can take those data sources, aggregate them together, and display them on a single dashboard. There's RBAC capability to be able to limit who can see what, and there's also thresholding and alerting availability, supporting some third parties like Slack or PagerDuty, even emails and send out webhooks. The demo I'm going to show today, this is the general setup. So we have our Avi controller, and we're pulling metrics from the API, and we're feeding those into a time series database. And then we'll be hitting Grafana, which will then pull those metrics into Grafana and display those in our dashboard. So let's jump into our demo. So I'm going to start just baseline on Avi, and this is my Avi controller. And let me log in as myself, and we'll show some of the analytics and metrics that come default out of the box. So here's a list, a login, here's a list of all of our services or virtual services. We have the concept of health scores, and there's multiple factors that feed into a health score, be it performance, resource availability, anomalies, and security. The health scores, obviously, as it says, is kind of give you a health of the application. Not necessarily, it's not a hard up or down. It's a health. So self-signed certificates will reduce the health of your security score. Certificates that are going to expire soon reduce that health score. And so right off the bat, we can see some of the smart analytics that are built into Avi that it shows us kind of how applications are performing. Expanding out my application here, we can see I have 3 pools associated to my virtual service and the pool members assigned to them. Again, each one with health scores attached. I see all my pool members. I can quickly hover to get their status and see this one was disabled, and this one is down because of our unresolved, which tells me either probably there's a network issue with the host is probably offline. And I have visibility into what I call the infrastructure or the service engine that's this virtual service is on, and I see the health score there. As I dig deeper into the virtual service, I get presented with per application metrics and visibility for this specific virtual service. So this is telling me how this application is performing. And the first screen I have here is my end-to-end timing. And this end-to-end timing is a chart that shows me where during the life cycle of a request the latency is. So they have an end-to-end timing chart up here. And here's the visual graph. But between the client and the load balancer, there's 71 milliseconds of round trip time. Between the load balancer and the server is 1 millisecond. Generally, there's about 40 milliseconds for an application to respond, and the 6 milliseconds for that data to complete transfer, for a total time of 118 milliseconds. I think off the bat, we can see the power here is when diagnosing slow performing applications, we can see at which point is slow, whether it's the client to load balancer, the load balancer to the server, or for the server to actually respond. And we have other metrics we perform too, as throughput, connections, open connections per second, and requests per second. One of the other benefits or the analytics we can provide in logs is we actually have visibility into requests. And this is HTTP, we have HTTP requests. And for each one of these, there's a wealth of information that's provided. So I can see the client IP, country of origin, operating systems, browser, at the SSL versions. I can see the requested, what they requested. I can see response codes, response length, and content type. So there is a tremendous amount of information that we expose through the UI, and that Avi keeps natively within the system. And all of this is we can expose via the API as well. And so this is just the baseline for what Avi keeps, just to provide some information for what out of the box we have and what we get. And so there's extreme power for the controller. You have full visibility into your application. But if we wanted to take a step further and consolidate our metrics, that's where Grafana comes in. That's where we're taking the metrics, we're exporting them out of the controller itself and importing it into that central location. And so now I'll move on to, I have some Grafana dashboards here, and I'll start with this first one. And so the way we've broken up these dashboards is we've broken up into what we see as the consumers of who this information is going to be at. And so as I mentioned before, we have a full wealth of information from Avi, ranging from layers 2 up to layer 7. And so there's points of interest for all teams within the organization, be it a NOC for a NOC just for status, and performance metrics, for NetOps for understanding how the network infrastructure is performing, how the load balancers are performing, to AppOps teams understanding how their application performing at layer 7. And so we've broken these dashboards up into, I'll kind of say, to meet the different interested parties. And so this first one I have, which I call sort of my summary, which really could cater towards a NOC or the NetOps. And so quick dashboard view, we have a visibility of what's going on within our deployment. And so we have quick snapshots for how many SSL TPS is going on, bandwidth, how many number of virtual services are up, and we can dig deeper into these metrics as well. And so all of this is coming from the controller. So you can see there's an immense amount of data. Virtual service configured, virtual service deployed, number of virtual services that are up, virtual services are down, CPU on our service engine. So we can see we have a CPU, one of our service engines actually run really, really hot. And so we can very, very quickly see if we were doing some sort of issue or event correlation, we can see, oh, we have a service engine. Very quickly see a service engine is running at 100%. You have bandwidth, concurrent connections, the virtual services that are up or down. And then we start getting into some of the cluster statistics. How many active members are in my controller cluster? This is a 3-node controller cluster. I can see which one's a leader. And as we're deployed within a vCenter environment, I have information on vCenter as well. Are we connected to vCenter? Have we done discovery within vCenter? As well as on our virtual environments as ESX. So we're hosting service engines on ESX. I can see how many of our service engines are on each ESX host. And so I can see that for one of them, the .118, we have 5 service engines. And the .115, there's 1 service engine. And then we go a step further and say, for each ESX host, how many applications are hosted on? And so we see there's a disparate that we're obviously we're more distributed towards .118 versus 117 or 15. Out of all of our virtual servers or applications we have deployed, 12 of those are on one virtual server or ESX host, and the other 2 have 2 and 1. And so this gives us visibility into our capacity. This gives us visibility into how we're dispersed across the infrastructure. And it's a prime example for taking multiple data sources and putting them on a singular dashboard so we can do correlation between assets within our environment. And so this dashboard is really catered towards like a NOC and NetOps. So it gives us like a 10,000-foot view of what's going on in this environment, how is it performing. And the other dashboards will start digging in and focusing more closely on specific components of the deployment. And so the next dashboard I have is for the service engines. And the service engines themselves, remember, are the load balancers. They're the ones that are doing the data plane, the ones processing, the user traffic. And this is a rolled up chart for service engines. So like top 5 for bandwidth, average bandwidth, and here's CPU. And one of the nice things about Grafana is you can set thresholds. So I have a threshold set here at 75%, and I can see that I have this service engine obviously exceed that threshold. And based off those thresholds, you could set obviously events like pager duty. You could send out alarms or alerts to say, hey, we've got a high service engine. But again, we've been able to very quickly, just from on a dashboard, identify this specific service engine, our HEUB, is running hot. We've also got capacity numbers, so virtual services per service engine. So I see that the VVCQ has 8 applications hosted on it. Most of the other ones all have 1. Tracking health scores, total number of service engines, packets per second, connection memory usage, connections per second, like heartbeats, and then per virtual service, which application is pushing the most. In this case, bandwidth, and down here, which one's actually doing the most SSL TPS. So this metric is broken down into this virtual server on this service engine is pushing this much data. And as you can see how granular we were able to get just within, I'm gonna call this our infrastructure tier, which is the service engines. We're able to grab an immense amount of data and display this very, very simply so you can get a quick idea of what's going on within the environment. Now this is again a service engine, so there's gonna be a big duplicate of information from the previous one, but this one is focusing on a single service engine. So as in the previous dashboard, we saw that service engine had 100% CPU. That's this service engine. I can quickly dig into the service engine and look at its specific performance metrics and try to figure out what is going on in the service engine. Why is it running hot? And so you can very quickly see at the top, CPU's at 100%. All right, so we know just visually, instantaneously as we brought this dashboard up, this service engine is being worked pretty hard. And so we have the bandwidth metrics, connection memory. And so as we dig down, we can start looking at some of the values and try to figure out what's pushing the CPU so hard. And knowing this device is a 1 CPU box, it's going to be the SSL TPS is pushing it really hard. And as there's only 1 virtual service on this service engine, but if there was multiple, say we had 20 or 50 virtual servers on the service engine, identifying which application is pushing the CPU, that's extremely powerful. So if I had, for the sake of the illustration here, let's say there was 20 applications on this service engine, being able to identify the heavy hitters for SSL TPS, which is processed in CPU, understand which application is pushing harder, I can visually see the heavy hitters. And at this point, I can make informed decisions about how to remediate, whether it's the flexibility of Avi, we can scale this virtual server out, so we're now active across multiple service engines, distributing the load across multiple resources. Or if there's a lot of service engines, we could be able to actually take the ability to move this virtual service to another service engine, moving the load off of this one onto another. The point, though, is we quickly have the ability to determine what's going on and make informed decisions for how we want to, how we want to take our next actions and what those actions may be. And so this is for the service engines themselves, which again, I'd say this is probably geared towards NetOps, the network infrastructure teams, understand how the infrastructure, how the load balancer itself is performing. What's the bandwidth? What's the connections per second? At their fingertips, we now have visibility into how we're performing, what is going on. The next dashboards we're going to go to are more catered towards app ops teams. And so here's where the self-service comes into play. Presenting this information to the application teams, in my experience, was extremely beneficial, 1 for me and 2 for them. For me, it was instead of playing a proxy for how's my application performing, and then me going, okay, let me look up, see if I can figure out what's going on. by exposing these dashboards, this information to them, they now have the ability to see how their application is performing, and they can make informed decisions off that. And we'll touch on that a little deeper as I move to the dashboard after this one. But this is a rolled up dashboard. This is a top value for all of our applications. So we can see which applications and how they're performing, sort of in this summary, if you will. So we can see the top for bandwidth, connections per second, concurrent connections, packets per second, and again, these are per application. This isn't per appliance. This is broken down per each individual application. And so we have the visibility, and there's a tremendous amount of data we can capture here. SSL certificates expired. Looks like we have one expired quite a few days ago. SSL TPS, we can see which ones are pushing the most SSL TPS. And again, these are summaries. This is good for reporting. We talked about historical trending. Hey, last week, which application was pushing the most data? Or hey, we saw a spike in throughput. Can you potentially see what was going on? Going back to the charts, looking at this roll-up data, we have the ability to now see, oh, at this time we saw this application, its bandwidth, it spiked. And then if you want to dig deeper into that specific application, that's where this next dashboard comes in. Following the same trend as the service engines, this one is a per virtual service dashboard, and we can scale it. We can look at different virtual services. I'll focus on this one specifically. But now, as an application team or app owners, they have complete visibility into the performance of their application. And so, as with the DevOps teams, they see my application performing here. Here's my standard baseline. If I do code pushes or I do a code upgrade, how did that impact my application? Do I see connection drops, or do I see one of the issues, I'll get that in a minute, but we have virtual server bandwidth, connection per second, concurrent connections. And again, now this is specific for an application. Obtaining this data for me historically was extremely, extremely difficult, but Avi allows us to be able to inform our end users or the consumers of our service for how their applications are performing. In exposing this to them, allows them to make informed decisions, be it scaling or upgrades, rollbacks, etc. So we can track bandwidth, virtual server status, is it up or down, server-side latency, pool members, pool members that are configured, pool members that are up, pool members are enabled. Packets per second, packet drops, tracking the health score, which service engine they're on, so we can look for if things have changed. Did it move from one service engine to another? Do we migrate it? SSL statistics. And here's one. This is one I really think. So be able to track response codes, so 400 or 500 response codes. This is helpful, again, going back to app teams. If they do code upgrades, they push a new application. Is there a spike? Do they see an increase in like 400 or 500 status codes? If so, they can make informed decisions. Say, okay, we're seeing increased error responses. Let's roll back to the previous version. To remediate any issues. Exposing this information, providing this self-service, allows them to make these informed decisions on how they make these informed decisions going forward, and it's extremely powerful and useful. And then we can track client-side open connections, and again track pool member specific information. So we can look at how load balancing is occurring, how the distribution is going across the backend web servers. This was a very, very quick demo of using Grafana to display Avi metrics. And then these dashboards are completely customizable for the information that you find important. But the point, or what I want to get across is there is a tremendous amount of information within Avi that we can expose, and it's important for all stakeholders within the organization. This is the point, as I just covered, this is the point that's really, really important. One of our big value adds is from Avi is we have analytics up and down through all the layers that is important for everybody, via the DevOps teams, a NOC, or NetOps. giving them visibility into how the service is performing and how their application is performing, combining that to be able to do quick issue resolution, event correlation, extremely powerful. So from the demo, these are some of the takeaways we should get. The benefit of centralized metrics, combining data from all of our data sources, event correlation, network, compute storage, load balancing, application analytics. Very, very, very powerful. The deployment is very scalable, very dynamic. Avi, we can scale up control plane, we can scale up the data plane to meet demand. This information is relevant for all of IT organizations and all stakeholders. This information, fast troubleshooting, issue identification, make informed decisions, and provide self-service metrics. Allow the teams to inform themselves, allow them to get this information. All very, very helpful. Here's some reference information. We have, first link there is for the metrics that are available through Avi. There's an extensive list. We have our knowledge base link, and then we have code examples within our DevHub site for actually pulling metrics. And there's actually have customers contributing to our GitHub for some of the methods they're using. A good example will be Prometheus. We have a customer providing a Prometheus agent and uploading that to GitHub for us. And then that I'll start the Q&A section. We have some links below, so if anybody wants more information, contact us, or if you're looking for a customized demo, you can schedule a demo that we can customize for your deployment in your environment, show you how Avi will work.
Thank you, Matthew. I would like to draw the audience's attention to the handout section of the webinar. We have our 2018 Load Balancer Buyer's Guide, an analytics solution brief, and also our 7 considerations for an LB refresh ebook. We have a few questions coming in. If you have any others, please type them into the questions window. Matt, the first question that we have here is, how does the controller capture all these metrics?
Sure. So as we have the distributed architecture between the control plane and the data plane, the data plane or the service engines themselves, as they're processing the data, they capture the information and they send it to the controller. And the controller will then munge all obviously the raw data to form the metrics analytics. So the data is being captured at the data plane, fed to the control plane and then obviously presented on the control plane itself. So it's all captured within the data plane and fed to the centralized controller.
Great, thank you. The other question we have coming in is on the retention of the metrics, and how long are these metrics retained within the platform?
Sure. So there's going to be two facets of that retention based off the demo I showed. So within the Grafana data source, it has its own retention period based off granularity. But natively within our controller itself, we can keep 5-second retention or 5-second granularity for about an hour. And then beyond that hour, we keep 5 minutes granularity up to roughly a week. And at that week, now we roll up to 1 per hour up to a year. And then beyond that year, it's 1 per day. So 5-second granularity to an hour, 5 minutes up to a week, 1 hour to a year, and then 1 day, one per day beyond that year.
Got it. Thank you. Looks like we have one other question here, and it's asking about if any proprietary tools are needed for exporting these metrics.
Sure. So no, nothing. We don't require any proprietary tools to export metrics. It's all API driven. So we don't make decisions, or we're not going to decide what tools you have to use. It's up to you. We can integrate into what you're currently using. So it's all API driven, not requiring any proprietary tools. You make the decision. We'll integrate into your environment.
Okay, here's we have one more question here,
Mhm.
and it's around how does the controller handle SSL sessions?
Okay. I'm not quite sure how. Not quite sure what the controller itself isn't going to handle. If we're talking the data plane, the controller itself won't handle the SSL connections. All of the SSL termination will be done at the service engine layer, down at the data plane. And so the data plane then will terminate all the, if we do SSL offloading, terminates all the SSL connections. The controller itself is simply just a management plane. And from our architecture, there's no reliance. The data plane can operate headlessly without the controller. So the controller goes down, data planes continue to function as is. So all of the data plane, all of the real user traffic will traverse through those the service engines. So the SSL termination is done at that tier, service engines itself. I hope that answered the question.
Yes, thank you, Matthew. So I think that is all the questions that we have for today. Again, as Matthew mentioned, you're more than welcome to contact us on our website, or if you'd like to schedule a custom demo, we'd be happy to schedule that for you. And this concludes the webinar for today. Thank you so much, everybody.